Hi dear friends and viewers, welcome back to our channel Vinay Kumar Basics of Physics. This is the right place to learn physics. Dear students, in this video we are going to discuss about the topic is vernier calipers. What is the least count of vernier calipers and how many types of errors are available in vernier calipers and how we can find out the correction of the errors and how we can take the measurement of the vernier calipers in any experiment, and how many questions will be given and how many possibilities for the giving the problems in examination like NEET, JEE, EAMCET. All these things are we are going to discuss in this video. Let's watch. Vernier calipers and ordinary scale. What is the difference between ordinary scale and vernier calipers? In ordinary scale we can find out the least value is up to 1 millimeter or 0.1 centimeters, while in case of vernier calipers we can find out the least value is 0.01 centimeters, 0.01 centimeters or 0.1 millimeter. Clear? In case of ordinary scale we can, in case of ordinary scale we can measure up to only 1 millimeter, but in case of vernier calipers we can find out the up to 0.1 millimeter. Clear? That is the main difference between the ordinary scale and vernier calipers. So here ordinary scale 1 millimeter means what? 0.1 centimeter. Here now 0.01 centimeters. So the same length we are going to be used, or we are going to be measured by using ordinary scale and vernier calipers. Then the value what we are finding with the help of vernier calipers, then only we will get the accurate value. So this is the difference between a ordinary scale and vernier calipers. Among these two, vernier calipers has more accuracy. The least count also it is less for vernier calipers only. And now here, how the structure of the vernier calipers, how it is designed. Let's see here. Vernier calipers consists of two type of scales. One is the main scale. And second part is the vernier scale. So vernier calipers consists of two parts. One is main scale and second one is the vernier scale. Look here, on board one diagram it is there. In that what you are finding, the one black color metal, that should be taken as here main scale. This is what? Main scale. On main scale, one division is equals to here 1 millimeter. 1 millimeter. Clear? In that one, here you have to observe there are A and C, two jars are available. These two jars are fixed. And now here, what we are finding in this one, this is a within blue color, that should be here vernier scale. Vernier scale. So in this vernier scale you have to observe 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 means the starting one is 0. This is the vernier scale 0 and this is the here main scale 0. You have to observe. This is the main scale 0 and this is the vernier scale. Vernier scale 0. So vernier scale division in this diagram, vernier scale consists of 10 divisions. 10 divisions. Clear? And these 10 divisions must be available in 9 millimeters of the main scale. 9 millimeters of the main scale. Clear? So again in this diagram you can observe here B and D. These two are variable or movable jars. Clear? So this is simply about the structure of the or design of the vernier calipers. The vernier calipers consists of one main scale that should be calibrated in the millimeters, and the vernier scale consists of here 10 divisions. And in this diagram you can observe here A and C, these two jars are fixed, and B and D are the movable. Clear? To find out the here any error is or not, how we can check? Means here simply one knob it is there, by pushing it we have to make that A and B and C and D must be contact. Clear? Here one knob it is there, with the help of that knob we have to make that B and C must be movable. When they are movable, up to we have to move A and B and C and D when both are comes in contact. When both are comes in contact, then we have to check, is there any coincidence between the zero division of the main scale and zero division of vernier scale. Clear? So when the zero division of main scale and when the zero division of vernier scale both should be coincide, then what you have to say? There is no error. Clear? No zero error. On that time, here you can take that how the reading should be taken. Here MSR plus VC into LC, that is the particular value of diameter or length whatever may be. Here MSR, VC, LC. Here MSR means main scale reading and VC means vernier coincidence and LC means what? Least count. MSR is the main scale reading, VC is the vernier coincidence and LC is the least count. Clear? So the reading should be taken as here MSR plus VC into LC. Now here the question is how we can take the MSR and how we can take the VC and how we can take the LC. Let's go for that. If you can take D diameter or if you can take length, the reading should be measured in terms of like MSR plus VC into LC. MSR means what? Main scale reading, and VC is what? Vernier coincidence, and LC means what? Least count. First we can discuss about the what is the least count and how it can be find out. So very simple. This is the formula you have to remember. Least count. LC is equals to 1 main scale division. 1 main scale division by number of vernier scale divisions. 1 main scale division by number of vernier scale divisions. Already we discussed here on 1 main scale 1 is equals to what? 1 millimeter. What is 1 millimeter? So 1 by and number of vernier scale divisions. So in this case we are taking how many? 10. 1 by 10. That is equals to what? 0.1 millimeter. 0.1 millimeter. So then obviously what read here LC is equals to 1 by 10, 0.1 millimeter means again that is going to be convert into centimeters like 0.01 centimeters. So LC is equals to 0.01 centimeters. This is a one type of model to find out the least count. Clear? And now we have another formula, it is there. What is that formula? Here least count is equals to 1 MSD minus 1 VSD. This is the another formula to find out the least count of vernier calipers. 1 main scale division is equals to 1 main scale division minus 1 vernier scale division. So already we discussed what? N number of vernier scale divisions. N number of vernier scale divisions equals to the N minus 1 main scale divisions. This is the you have to remember. N number of vernier scale divisions is equals to N minus 1 number of main scale divisions. That means what? 10 divisions must be, 10 divisions of vernier scale must be available. 9 millimeters of part of the main scale. Clear? 10 millimeters should be available 10 divisions of the vernier scale must be available in the part of 9 millimeters of the main scale. That's why we can write n VSD is equals to n minus 1 MSD. Then what did here n VSD? Then VSD means what you have to write n minus 1 by n into MSD. We can write VSD is equals to what? N minus 1 by n into MSD. So you have to remember number of vernier scales division is here more than the number of divisions on the main scale. Sometimes some special cases number of vernier scale divisions is more than the S. Here number of vernier scale divisions is more than the main scale, the number of main scale divisions. Clear? Got it? In the same manner, sometimes number of vernier scale divisions is lesser than the number of main scale divisions. Clear? So VSD is equals to what, right? n minus 1 by n into MSD. So now here the same example what we are taking here, VSD, 1 VSD is equals to what? N minus 1 by n. N means what? Number of vernier scale divisions. How many we are taking? 10. 10 minus 1 by 10 into S, MSD. Here 10 minus 1 means what? 9 by 10 MSD. So therefore 1 VSD is equals to what you can write? 9 by 10 MSD. Clear? So now we have to substitute the 1 VSD value in this one. 1 VSD value in this one. Then what we get? Here LC is equals to 1 MSD minus 9 by 10 MSD. Then MSD is common. Then what is 1 minus 9 by 10 into MSD. Again what is 10 minus 9 by 10 into MSD. Clear? So 10 minus 9 is what? 1 by 10 MSD. 1 by 10 MSD. Clear? That is equals to what? LC is equals to here what, right? 1 by 10 MSD. So what is the 1 main scale value? 1 millimeter. 1 by 10 into 1. Therefore 0.1 millimeters. Again that should be turned into centimeters like this, 0.01 centimeters. So in this way we will find out the least count. So you have to remember the two formulas. First one is what? LC is equals to S by N. What is S? 1 main scale division. What is N? Number of vernier scale divisions. And second formula is what? LC is equals to 1 MSD minus 1 VSD. And to find out the VSD value, you have to remember N VSD is equals to N minus 1 MSD. So what we have taken example, in this case 10 divisions of vernier scale must be available in the portion of 9 millimeters of main scale. In this case number of vernier scale divisions is more than the number of divisions of main scale. This is the one case. And sometimes vernier scale division value is less and main scale division value is more. That is a special case we will discuss in the while we are doing the problems. Okay, this is the way to find out the least count. Now how we can take the MSR and how we can take the VC. How we can take the reading of particular object by using vernier calipers. Let's discuss. First thing we have to find out the whether the instrument has any error or not. We have to check it. So for that I already told you what it is. By moving these two jars B and D, already I told you here A and C, these two are the fixed and B and D are movable. With the help of this screw we have to make that A and B and C and D must be comes into the contact. Up to we have to move the A, C must be comes in contact with the B and D. Once these two are comes in contact and these two are comes in contact, we have to check whether the main scale 0, and vernier scale 0. This is the reading on main scale and this is the reading on vernier scale. vernier scale 0 and main scale 0 must be comes in a line. When they are coincide, there is no zero error, no zero error. Then you can directly take the reading like L is equals to MSR plus VC into LC you can take. So for example, this is the one cylinder and that should be kept like this. That should be kept like this. So after inserting the one cylinder in between A and B, now how we can take the MSR and how we can take the VC. So here MSR, main scale reading, after keeping the object in between the two jaws, these two are the lower jaws and these are called internal jaws and these two are called external jaws. When the object is kept between the external jaws, we have to take the MSR in such a way that how it is, the zero division of the vernier scale, must be coincide with the one division on the main scale and that should be taken as the main scale reading. After inserting the object between the two external jaws, we have to check the coincidence of zero division of vernier scale and one division on the main scale. Look here, for example, in this case, this is the zero of vernier scale and now it is the 2. The zero division of the vernier scale is coincided with the 2 centimeters. Then here what we can take, MSR is 2 centimeters. After inserting the object between A and B where the zero division is coincided with the main scale, then that particular value on the main scale should be taken as MSR, that is here now 2 centimeters. Clear? After that you have to check after the zero, the remaining 10 lines, which division is coincided with the any one division on the main scale. That should be taken as here vernier coincidence. In this case 1, 2, 3, 4, fifth line is coincides with the 2.5. Clear? So here this is what 2.5 on the main scale. Now here this is the vernier 0, 1, 2, 3, 4, 5. Fifth line on vernier scale, is coincided with the 2.5. Now which line of or which division of the vernier scale is coincided with the any one of the main scale? You have to check the two coincidences. First one is you have to check the where we are coincide is zero division of the vernier scale along with the one main scale. That should be taken as main scale reading. After that you have to check the another coincidence. What is after this zero remaining among the 10 lines, which line is going to be coincide with the any one of the main scale reading? That particular vernier scale division is taken as the vernier scale coincidence. That is what we see. So fifth division on the vernier scale is coincides with the 2.5 of main scale. Then here 5 should be taken as vernier coincidence. So VC is equals to what? 5. Already we discussed what is the least count here in this case, 0.01 centimeters. Then obviously we have to substitute those values. L is equals to MSR. MSR is what? 2 plus VC is what? 5. 5 into 0.01. That means what? 2 plus 0.05. That is equals to what? 2.05 centimeters. So this is the length. So in this way we can take the value when there is no zero error. So the measurement value should be taken as like this when they do not have any zero error. If any zero error is there in the instrument, then how we just now only we discussed when both external jaws are coincide, then zero division of the main scale and vernier division of the zero division of the vernier scale must be coincide, then there is no error. Clear? So how it is like this here. See the first one here. See, look at the first diagram here. When both studs here, what we are showing like this here, two jaws are there. when these two jars are comes in contact, you have to observe, is there any coincidence of, this is the zero division of the main scale and this is the zero of vernier scale. Clear? When both jars should be comes in contact like this, both should be come very close, there is no gap between those two. Clear? When both jars are comes in contact, we can get it like this. This is the, what we are finding, this upper portion is main scale and the lower portion is vernier scale, and this is what, zero division of the main scale and this is the zero division of vernier scale. So you can observe here, within the 9 millimeters of the main scale, 10 divisions of vernier scale available. You can observe, within the portion of 9 millimeters of main scale, 10 divisions are available. Clear? That's why what you can write, n VSD is equals to n minus 1 MSD. Clear? So when both jars are comes in contact, we have to observe zero of the main scale and zero of the vernier scale must be coincide. When they both are coincide like that, then there is no error. That's so simply what you have to say, no zero error. When both jars are comes in contact, we are getting like this. How it is? This is the zero division. This is the zero division of the vernier scale and this is the zero division of the main scale. This is what? Main scale zero division. And this is what? Vernier scale zero division. How it is? The vernier scale division is the left of the main scale. Left of the main scale. That means what? Both are not coincide. When both are not coincide, some error is there. Now we have to say that whether it is negative error, positive error. When we can say that the error is negative. When we can say that the error is negative, the zero must be passes and crosses the main scale zero. The zero division of the vernier scale must be crosses the zero division of the main scale. Then that error is called negative zero error. Negative zero error. Here simply what it is? This is the here vernier scale division and that should be left of the main scale division. Then that error is what we call negative error. If the zero of vernier scale lies to the left of the main scale, this is the right side and this is the left side. Left of the main scale 0, then the error is said to be negative error and correction is positive. Then how we can take the error magnitude of error? How we can take the magnitude of error? Simply here, that is MSR plus VC into LC. VC into LC. So here MSR value, what is MSR value? Where the zero division coincide, that is the MSR. But here nothing is there, that's why simply in this case MSR should be taken as 0. And VC, among these 10 lines, the second line is going to be coincide here. That's why I am going to take VC is the 2 and already we know that VC is what? 0.01. Then what at 0 plus 0.02, we will write 0.02. This is the negative 0 error. Minus 0.02 is the negative 0 error. Negative 0 error. And the correction should be taken as here plus 0.02. Plus 0.02. So I already told you what it is, how we can take the reading. So for example here L is equals to MSR plus VC into LC. MSR plus VC into LC. After inserting the object between two jars, we are taking some cylinder and that should be kept in between the external jars. Then again we can find out the MSR, again we have to find out the VC and already we know the LC. Clear? Already we discussed how we can take the MSR. After inserting the object between two external jars, the zero of the vernier scale division must be coincide on the one line of the main scale. That particular line on the main scale should be taken as the MSR. And the among the 10 divisions of the vernier scale, the one line should be coincide with the one main scale division. Among the 10 vernier scale divisions, one division of the vernier scale divisions must be exactly coincide with the one main scale division. That particular main scale division here not considered because we are taking the vernier coincidence. That's why we have to take the value on vernier scale. the division which can coincide with the main scale, that particular division should be taken as VC. So we already discussed, that's why I am going to directly here. L is equals to here some 5 plus 3 into 0.01. Here now 5 plus 0.03. What we write here, 5.03 is the here answer. We are doing the experiment with the vernier calipers that has negative error. Then here what you got, L is equals to 5.03, and already there is some error is there. How much it is there in the instrument? Minus 0.02. Then what you have to do? We have to do the correction. So that's why here 5.03 plus 0.02. Then the correct value is what? 0.05 centimeters. So in this way we can do the calculation when the vernier calipers has negative 0 error. Now let's discuss about the positive error in case of vernier calipers. Dear students, if there is no object between the two jars, that means what? Simply, for example, these two are the external jars. When these two are coincide, this is the one jar and this is one jar, this is the fixed one and this is the movable. When these two jars are comes in contact, if 0 division of the main scale, this is the main scale 0 and this is the vernier scale 0, both are coincide, then there is no 0 error. Clear? So in the absence of object between the two jars, we have to make that two jars must be comes in contact. Then if that in that vernier calipers we are finding like this, how it is, this is the 0 division of vernier scale and this is the main, this is the 0 division of the main scale and this is the 0 of vernier scale. This is vernier scale and this is the 0 of main scale. How it is, now 0 division of the vernier scale is right side of the main scale. This is the main scale division. The 0 division of the vernier scale must be right of the main scale, like this. Then the error is called positive error or positive 0 error. In a vernier calipers, when both jars are comes in contact, then we have to check whether 0 division of the main scale and 0 division of vernier scale both are coincide or not. If both are coincide, then there is no error. If the coincidence should be like this, how it is that the 0 division of the vernier scale is the right of the main scale, then that error is said to be positive and correction is negative. So here how we can take the magnitude of error? How we can take the magnitude of error here? Very simply, now error magnitude, how we can take MSR plus VC into LC. So here MSR, what we know MSR, where 0 division must be coincide, there it is called, this is the MSR. But here there is no coincidence, that's why here we will take this value is 0, and you can check here among these two are coincide, these two are coincide. This is the 8th division, that's why I am going to take 8 into LC is 0.01. then what is here, 0 plus 0.08, then the error is what, 0.08. this is the positive error and correction is negative. So for example, while we are taking the reading, for example, now in between these two external jars, one cylinder should be kept. So here this is the one jar and this is the another jar. Now here we have to keep the one object. So by doing already we discussed the procedure, the length should be taken as here now 6 plus 0. What do you know, MSR plus VC into LC we know. So here 6, MSR is 6 we are saying, and VC is some 8 and LC is 0.01. Then what is here, 6 plus 0.08 we will get. Then what is 6.08 centimeter is the answer here, 6.08. But what is the error here, error of instrument, plus 0.08. Now we have to take the minus. So corrected value 6.08 minus 0.08. The error is positive, then the correction is negative, then what here get 6.00 centimeters. So in this way we will find out the errors in case of vernier calipers. Now let's see some example problems which are given in the previous examinations. Let's go for that. Let's see one example. It was given in the 2003 JEE entrance, JEE mains. The question should be like this: n divisions on the main scale of a vernier calipers coincide with the n plus 1 divisions on the vernier scale. If each division on the main scale is A units, determine the least count of the instrument. See once again, n divisions on the main scale of vernier calipers coincide with the n plus 1 divisions on the vernier scale. If each division on the main scale is A units, determine the least count of instrument. So here, what vernier scale was given? Simply, how many divisions on the vernier scale? Vernier scale consists of, vernier scale has n divisions on the main scale and n plus 1 divisions on the vernier scale. So n plus 1 divisions on vernier scale is, and main scale has how many divisions? Is equals to n divisions, and he was given one main scale division is equals to what? A he was given. And what you have to find out? We have to find out the least count. That was the question here. So least count formula, already we know that what it is: 1 MSD minus 1 VSD. This is the formula, 1 MSD minus 1 VSD. So according to that, what he was given? N plus 1 vernier scale divisions is equals to n main scale divisions. N plus 1 number of vernier scale divisions equals to n main scale divisions. Then here from that, what right? 1 VSD is equals to what right? N by n plus 1 MSD. So this is the value of one vernier scale division. You have to substitute here. Then LC is equals to 1 MSD minus 1 VSD value is what? N by n plus 1 of MSD. Here MSD is the common. Then what you can write? 1 minus n by n plus 1 MSD. So already MSD is common here over. Then MSD of LCM, n plus 1 minus n by n plus 1, and n cancel. Then what you here? MSD into 1 by n plus 1. MSD value is what? A. Therefore what right? A by n plus 1. This is the least count. This is the least count of the instrument as per the problem. See the next example. It was given in the NEET 2019. The main scale of vernier calipers has n divisions per centimeter, and n divisions of the vernier scale coincide with the n minus 1 divisions of main scale. The least count of the vernier scale is, the given information is n number of main scale divisions, is equals to, for what? 1 centimeter, in 1 centimeter. N number of main scale divisions available in 1 centimeter was given. And next thing is what? N number of vernier scale divisions. N number of vernier scale divisions is equals to n minus 1 divisions of main scale. N minus 1 divisions of main scale divisions. So that is the given data. We have to find out the least count. So already what we know, least count is equals to what formula? 1 MSD minus 1 VSD. 1 main scale division minus 1 vernier scale division. So here simply you can take this one. The condition is what? N VSD is equals to n minus 1 MSD. From that what you have to write? VSD, 1 VSD is equals to what? N minus 1 by n into MSD. So this is the value of 1 VSD. You have to substitute here. LC is equals to 1 MSD minus n minus 1 by n MSD. Again, what have to take common? We have to take MSD is common. Then what, write MSD of 1 minus of n minus 1 by n. Then do LCM. MSD is in of n minus 1 by n. That is equals to what? MSD of n minus n, cancel minus of minus plus 1 by n. So least count is equals to what? MSD into 1 by n. So what is the value of 1 MSD? What he was given? N MSD is equals to 1 centimeter. Then 1 MSD is equals to what? 1 by n centimeter. So 1 MSD value is what? 1 by n centimeters. Therefore substitute here. Therefore LC is equals to MSD into MSD of 1 by n. So MSD value is what? 1 by n. So 1 by n of 1 by n, that is equals to 1 by n square. 1 by n square. This is the least count of the vernier calipers as per given problem. Clear? See the next question. It is also given in JEE 2010. A vernier calipers has 1 millimeter makes on the main scale. It has 20 equal divisions on the vernier scale which match with the 16 main scale divisions. For this vernier calipers least count is, a vernier calipers has 1 millimeter marks on the main scale. So simply what is, so one main scale division he was given, how much it is? Equals to 1 millimeter. And next what you are saying, 20 equal divisions on vernier scale. So NVSD, how much here? 20 vernier scale divisions, which match with the n minus 1 main scale. So n minus 1 MSD here, simply what you have to say, 16 main scale divisions. So directly you can write the formula here. 20 vernier scale divisions is coincide with the 16 main scale divisions. That is the given here in the problem. Now what you have to write? We have to find out the least count. Least count formula is what? Least count formula is 1 main scale division minus 1 vernier scale division. This is the formula we are going to use. And now here, what write here? 20 VSD is equals to 16 MSD. Then 1 VSD is equals to what you have to write? 16 by 20 MSD. So 2 8s are 2 10s are. Then what it is? 0.8 MSD. So 1 VSD is equals to what? 0.8 MSD. So then obviously here you can substitute here. LC is equals to 1 MSD minus 1 VSD value, what is? 0.8 MSD. Here MSD is the common, that is equals to 1 minus 0.8. So therefore then LC is equals to MSD of 1 minus 0.8, that is equals to what? MSD into 0.2. Already 1 MSD what was given? 1 millimeter. That's why here 1 into 0.2, that is what? 0.2 millimeters. So among the four options, fourth option is the right one. D option is the correct one. Dear students, if you want to expect more videos and more concepts from my side, then please support my channel and subscribe my channel and share my channel to your friends. So to encourage my channel, please support my channel, then only the content will reach to the more people, then everybody can get some benefits. Okay, thank you for watching.